So, question 11. We are told the line y is x plus c is tangent to the graph of f of x is equal to e of x, and we have to obtain the coordinates of the point of intersection, in other words, the point of tangency of this line to this graph. So that means that we need the derivative of f to equal 1 because the gradient of this straight line is 1. The derivative of e to the x is e to the x, so we need e to the x is equal to 1, which means x is equal to 0. So we didn't even have to get the lid off our calculator for this one. And they asked for the coordinates, so that means we've got to actually say, so when x is 0, then substitute 0 into the function, and e to the 0 is 1, so it's 0, 1. 2 marks in the bag. What's the value of c? Well, that's just got to be 1, because this is actually the y-intercept of where they intersect is at the y-intercept. So c has got to be 1. So that's done, and then we get 1 mark for sketching the graph of f of x and the tangent on the axis below. Let's have a look at the axis below. So here we go. I've just taken a screenshot off ClassPad. There was no scale on the axis here, and it's only 1 mark, so you've got to do quite a lot here. Typically a sketch involves putting some kind of scale, so I think I'd put a little mark at 1, draw my exponential function going through very flat to the origin up to about -3, and then starting to rise off the axis going through 1 and then rapidly increasing, and then pop in the line y is equal to x plus 1 as a tangent, just making sure that it's clearly a tangent, and pop some kind of scale on this axis as well, so that using the gradient of this line to check it's okay. A lot going on there for 1 mark. Anyway, then we need to turn the page to get to part D. So part D, we've got to evaluate the exact area between the function, the tangent, up to where x is equal to log 2. So time to get ClassPad out. Here we go. Let's get the functions happening. So from the keyboard, we'll get an e to the x, and we want an x plus 1, and that should get us going. So we'll go into graph mode here, and we'll take e to the x and drop it downstairs, take x plus 1, drop it downstairs. I'll do a box zoom in on the kind of bits of the graph that we're interested in here. Looks like about there. So we need the area between it, so we're going to need the integral of the top function e to the x minus the lower function x plus 1 between 0 and log 2. We're asked for it exactly, so we're going to have to do it upstairs. So here we go. We'll get the keyboard out. We'll go down to Math 2 and choose the integral template. For difference of functions, I always recommend we go to Math 1 and set up a box for the first function minus another little box for the second function. Start filling in from the back end. Into here goes x plus 1. Into this box is e to the x, and we want to go from 0 to log 2. So natural log of 2. We're in standard mode, so we're going to get an exact answer. Tap execute, and there it is, basically. Sometimes it looks a bit ugly, and we can tap the sync button to see if things get any better, but nothing really changed there. It just removed the negative sign and made it positive. But I think we'll go with this solution up here. So we write it down. We may as well start doing it backwards. We'll have a 1 minus a log 2 minus a half of a log 2 all squared on that one. So that's part D, 3 marks, the calculator doing all the work for us. And then part E, given that g of x is the inverse function of f of x. Now, that's a syllabus dot point that the inverse of the exponential function is the natural log function, so we know that g of x is log x here. We've got to write a definite integral that could be used to determine the area between g, the x-axis, and the line x is log 2. Let's have a quick look at that again on our ClassPad. So if we have got the natural log of x, and what was the other function there? Yeah, the line, the x-axis, right. So here we go. We'll get our bit of graph paper. I'm just going to shut that window and open it again just to clear it up. So when we take the log function downstairs, and the log of 2 was where we had to go, so I'll just if I bring that down to here, we actually want the line x is equal to log 2. So let's drop that one downstairs. So, oh, look at this. We're after this teeny little area in here. So we can see exactly what we need to do. It'll be the integral from the lower limit will be log 2. The upper limit will be 1, where the log cuts the x-axis here. And on top is the line y is equal to 0. So we have a 0 at the beginning minus the underneath function, which is log x. And so it's only 2 marks. We actually don't need to go there.